Question is to clear the concepts when a charged particle moves in a magnetic field B. Force is experienced and that is given by Q V cross B. V cross B. And direction of force is given by Fleming's left hand rule or Fleming's right hand palm rule. The two rules to find the direction of magnetic force experienced by a charged particle moving in magnetic field. Now, what is Fleming's left hand rule? Fleming's left hand rule, this is the left hand. This is the thumb. This is the forefinger. This is the middle finger. The middle finger. The forefinger, middle finger, right? Then, if this indicates direction of magnetic field, this indicates movement of direction of positive charge, then this is the direction of magnetic field. Direction of magnetic force. Means if we take left hand of and keep these three mutually perpendicular to each other, then this indicates, if this indicates magnetic field, this indicates direction of positive charge, direction of motion of positive charge, then thumb will point toward the direction of force. This is regarding the Fleming's left hand, right? This is for positive charge. If negative, then the direction will be reverse. One is right hand palm rule. Right hand palm rule, when the fingers of your right hand around the line perpendicular plane of V and B is shown in the figure like this. This is the right hand. This is the thumb. This is the fingers curling. Wrap the fingers of right hand around the line perpendicular to the plane of V and B. Perpendicular plane of V through a smaller angle so that they curl around with sense of rotation from V to B through smaller angle. V to B we can move from this angle, we can move from this angle. This is the smaller angle. This is the smaller angle. Then, if this condition is satisfied, then this will indicate the direction of force of positive charge. This indicates direction of positive charge, right? Also, V cross B means Fm is perpendicular to V, Fm is perpendicular to B. Means work done by magnetic force is 0 for static B. That is equal to, if we take F by QVB sin theta, theta equal to 0, parallel, theta equal to 180 degree, anti-parallel, magnetic force is 0. Theta equal to 90 degree, Fm is maximum, right? This is all about the concepts of charged particles moving in a magnetic field, right? Next question. Question is, a charged particle is projected in a magnetic field B, 3I plus 4J into 10 to the power minus 2 Tesla. The acceleration of the particle is found to be xi plus 2J meter per second square. Find the value of x. Concept applicable. We know magnetic force. When a charged particle enters in the uniform magnetic field, it experiences a force. The action of force is given by V cross V. Means Fm is perpendicular to V. Fm is perpendicular to V. You know A cross B. Answer is C. Another vector. This is 90 degree and this is 90 degree. This is A, this is B, this is vector C. So A is perpendicular, C is perpendicular to A, C is perpendicular to B. C is perpendicular to the plane of the A and B. Now, as F is perpendicular to B, therefore A will be perpendicular to B. A will be perpendicular to B. Therefore, A dot B will be equal to 0. You know the formula? A dot B is given by A1I plus A2J plus A3K dot B1I plus B2J plus B3K equal to A1A2 plus A1B1 plus A2B2 plus A3B3. This is also equal to magnitude of A, magnitude B into cos theta. Depending on the requirement, जो चाहिए वो हम find out कर सकते हैं, right? Therefore, A is given to you xi plus 2j, xi plus 2j dot 3i plus 4j into 3i plus 4j into 10 minus 2, that is equal to 0. That is 3x plus 8 equal to 0. X equal to minus 8 by 3. What will be the unit of x? Because x is in the expression of acceleration, the two things can be added or subtracted when they are dimensionally same. So its unit will be meter per second square. This is the answer. Right? Next question. Question is a magnetic field of B 4 into 10 to the minus 3 along z direction. Tesla exerts the force of this much on a particle having a charge of 10 to the minus 9 coulomb and moving in the x-ray plane. Find the velocity of the particle. As velocity is in xy plane, let v equal to vxi plus vyj. Right? What is this? Concept applicable is when a charged particle enters in a uniform magnetic field, it experiences a magnetic force given by Q V cross B. Right? So in that case, this is given to 4.0 I plus 3.0 J into 10 to the power minus 10 equal to 10 to the power minus 9 into V. Vxi plus Vyj cross B4 into 10 to the power minus 3 K Tesla. Right? Now, 4 into 10 to the power minus 12, this comes out to be Vxi plus Vyj cross K, right? This is forces. Okay. Now, cross product regarding I J K. I cross J is K. J cross K is I. K cross I is J. Cross product is not commutative. That is, A cross B is equal to minus B cross A. Using this concept, we will expand it. This comes out to be now 4 into 10 to the power minus 12 I cross K. I cross K reverse minus J minus Vx into J. J cross K. J cross K I plus Vy I. This comes out to be 4.0 I plus 3.0 J into 10 to the power minus 10. Now comparing. Comparing means component of fact, component this. So this comes out to be minus Vx will be equal to minus Vx will be equal to J component. J component is 3 into 10 to the power minus 10 upon 4 into 10 to the power minus 12. So this comes out to be 3 into 100 divided by 4, that is 75 meter per second. So Vx comes out to be minus 75 meter per second. Right? Similarly, Vy will be equal to, that is multiplier of I, 4 into 10 to the power minus 10 upon 4 into 10 to the power minus 12. So Vy comes out to be 100 meter per second. Therefore, velocity will be equal to Vxi minus 75 I plus 100 J meter per second. That is the answer. That is the In this session of moving charge and magnetism, very basics discuss on these topics through illustrations. If any doubt, please comment. In further session, we are going to discuss all these. Being very, very important for all, it is requested to go through the session completely. Now let's move further. Question is, that is, concept applicable in today's session is path of a charged particle in uniform magnetic field. You know, Fm equal to Q V cross P. V cross P force. Magnetic force. Magnetic force experienced by the charged particle, positive charged particle, is given by this formula. So V is the velocity of the charged particle enters in uniform magnetic field. Right? In that case, F equal to Q P V sin theta. Theta is angle between V and B. Angle between V and B. Right? And direction of a magnetic force, direction of magnetic force Fm is given by Fleming's left hand rule or right hand palm rule. Right hand palm, right? Right hand palm rule. Now, there are three cases: path followed, path followed by charge particle when entering the uniform magnetic field. Theta equal to 0 or theta equal to 180 degrees. This is a case 1. In that case, Fm equal to 0. That is, charge particles moves in the undergravity, right? Second, if theta equal to 90 degree, if theta equal to 90 degree, then it follows circular path, as F perpendicular to B, F perpendicular to B, as F perpendicular to B. In this case, centripetal force is provided by magnetic force, right? Now, therefore, Fm provides mv square by r, that is qvb. Then r comes out to be this v goes mv over qv, mv over qv. Now, as kinetic energy given by half mv square multiplied with half m square v square by m. Therefore, p square by 2m equal to k. Therefore, p equal to twice m k. Also, potential difference work done by periodic charge. Therefore, k is also given by q into p. Using all these things, R can be written as mv upon bq or p upon bq or twice mk under root upon bq or twice m qv upon bq. Depending on the requirement, we can use anyone. Right? And one is time period of something. Time period. You know, speed is equal to distance upon time. The time period t will be equal to distance in one solution 2 pi r divided by the velocity. 2 pi r की जगह पुट कर दिया हमने mv upon bq into v. This is so time period 2 pi m by q. From this, f equal to 1 by t and omega equal to 2 pi f. We can find any relation. This is regarding the path followed by the charge particle when it moves at angle theta equal to 90 degree, right? Third case, theta is not 0 or a 180, theta is not 0, 90 degree, and theta is other than this. In that case, what will happen? Resolve velocity in two components. One is V parallel to electric magnetic field, V cos theta, one V perpendicular to V sin theta. Right? This component responsible for straight motion. This is responsible for circular motion. Combined effect is path followed is helical. Path followed is helical. Path followed is helical, like this and this. Right? One term in this case, pitch of helix. Pitch is, that is the distance. Distance is given by horizontal component velocity V cos theta into time period. V cos theta into time period is 2 pi m by dq. 2 pi m by dq. This is all regarding the concepts applicable when charged particle enters in uniform, that it follows the path. Path किस तरीके से travel करेगा, this I have explained here in detail. Right? Next question. Question is, two particles A and B. This is A, this is B. Of masses m and v respectively and having the same charge are moving in a plane. A uniform magnetic field exists perpendicular to this plane. The speed of the particles are v and vb respectively, and trajectories are shown in the figure. This is the figure. In this case, Ra is greater than Rb. Right? You know, when a charged particle enters in uniform magnetic field at an angle theta, then R equal to mv by bq or P over PQ or twice MK over PQ or twice MQ into V upon PQ. You have to pick up according to the requirement of the question. In this case, charge is same, and B is same. Both will be consumed in constant of proportionality. Right? Now, in this case, which will be applicable? Mass is same, having the same charge and moving the plane uniform vector perpendicular to the speed of the particles v and vb, and the trajectories are shown in the figure. In this case, R equal to mv over vq. V is same, so R proportional to charge is same proportional to mv, as R is greater than Rb. Therefore, MA V is greater than MB. We check the option which is the correct option. B option is correct. Option B is correct. Option B is correct. Right? Next question. Question is, a proton, a deuteron and alpha particle having the same kinetic energy are moving in a circular trajectories in a constant magnetic field. If Rp, Rd and R alpha denote respectively the radius of the trajectory of these particles, then we have to pick up one of the correct answer. Again, concept applicable is when a charged particle enters in a uniform magnetic field, it follows it. So path of theta is 90 degrees. R is given by mv by bq or p by bq or twice mk by bq or twice m 2 into v upon v. Pick up any as per the requirement. Now given is proton, deuteron have the same coordinates. K is same, B is same, K is same, B is same. Then this concept will be applicable. Therefore, R will be proportional to under root m by q. Root m by q. This is constant proportion में consume कर दिया, this को constant proportion में consume कर दिया. Therefore, R alpha is to R deuteron is to R proton equal to R alpha mass under root 4 divided by 2 is to deuteron under root 2 upon 1 is to under root 1 upon 1. That comes to 2, 1 is to root 2 is to 1. Means R alpha and R alpha equal to RP. And RD is greater than R alpha and RP. Means pick up the answer which is correct. R equal to R alpha. This is correct, and RD is greater than. A option is the correct option. A option is correct. Option A is correct. Right. Next question. Question is, two particles X and Y having equal charges after being accelerated through the same potential difference enters a region of uniform magnetic field and describes circle path of radii R1 and R2 respectively. Ratio of masses X and to that of Y is, four options are given to, one of the option is correct. Again, radius of circle path when charged particles move in a magnetic field at an angle theta to the magnetic field. That is mv over r dq equal to p over dq or twice mk over dq or twice m qv on dq. Pick up one of the correct which is to be applicable. In this case, V is same, Q is same, V is same. V is here, Q is here. This will be, and V is also same. All will be consumed in constant of proportionality. Constant of proportionality. Therefore, R proportional to under root M. Therefore, what is given to you? M proportional to R square. Mx over My equal to R1 over R2 or this. This is the answer. Check up. C option is correct. Option C is correct. In this session, up to now, we have gone through all through very basics cleared through illustrations. In further session, we are going for these. Up to this, if any doubt, please comment. Now let's move forward. Concept is magnetic force on a current carrying conductor. In earlier sessions, we have discussed Fm equal to Q V cross P. Means when a charged particle enters a uniform magnetic field, it experiences a magnetic force. Direction of this is given by Fleming's left hand rule or right hand palm rule. This is for positive charge. This is for charge. And that is equal to QVB sin theta. Theta is the angle between V and B. Right? This was discussed in magnetism, very basics one. Right? Then further we'll discuss path followed by charged particle moving in magnetic field, uniform magnetic field. That will be straight line, that will be circle, that will be helix. All these three concepts were discussed in magnetism, very basics, session 2. Right? Now in this session, I am going to discuss force experienced by current carrying conductor. Force experienced by current carrying conductor. That is given by Fm equal to I L cross P. That is ILB sin theta. Current is flow of charged particles. Flow of charged particles. Now, direction of conventional current. Direction of conventional current. Direction of conventional current is opposite of electronic current. Therefore, they can be considered as plus Q charge. This can be considered as a plus Q charge. Right? Now, L is length vector and generally it is applicable for straight conductor, right? But for arbitrary shape, as B is constant, I is constant, so B into I dl, dl, right? Dl. Suppose this is a conductor, this point A, this point B. We join this. Current is flowing like this. So ये पॉइंट सी है, ये डी है, ये बी है. वायर सेक्शन इज ए सी डी बी. What will be dl? But dl vector will be equal, dl will be, that is integrate, dl will be equal to L, that is distance between initial and final position. Distance between initial and final position. Therefore, here dl will be equal to AB. dl will be equal to AB. Right? For closed loop, suppose in this case, circle current is there, like this. In this case, net force Fm is 0 and torque equal to also 0. But if we take a square, suppose this is the magnetic field, this is the magnetic field. Suppose this is the direction of flow, and this is the, one will be this, one will be this. In this case, Fm will be 0, torque will not be equal to 0. To equal and opposite, the line of action will be different. Line of action will be different. Therefore, they will constitute a torque also. Right? In this complete session, main thing is to find dl. dl is generally to be taken distance between initial point and final point of the current. For closed loop, it is equal to 0. Now, let's start with the next question. Question is, in the figure shown, a semiconductor wire loop is placed in a magnetic field B equal to 1.0 Tesla. The plane of the loop is perpendicular to the magnetic field. Current I equal to 2.0 ampere flows in the loop in the direction as shown. Find the magnitude of the magnetic force in both the cases. Concept, applicability and solution. There are two figures. This is figure 1. It forms a closed loop. Does not form closed loop. You know, magnetic force is given by I L cross B, I L B sin theta, theta equal to 90 degrees. Right? Now, case 1. For closed loop, as L equal to 0, that is the distance between initial and final position is same. Therefore, Fm equal to 0. In case 2, in case B, this is given to, so this point is C, this point is C, this is A, this is B. Now, current in the wire ACB, and current in the wire AB. In this case, both lengths will be considered same as distance between initial and final position is same. Therefore, for both wires, FACB will be equal to FAB. Therefore, we can take ACB, AB means twice AB equal to length, right? Now, therefore, magnetic force will be equal to Fm will be equal to I twice AB into B, that is the 2R diameter, 2 into 2R into B. On substituting the values, we get 2 ampere, 1 Tesla. 2 ampere, 2 into 2 into 1 Tesla into 1. That is 8 Newton. That is the answer. I think concept is clear regarding the L vector and for closed loop, right? In this session, up to now, we have gone through all these. If any doubt, please comment. Further, we are going to discuss on these topics. Being very, very important for all these, it is requested go through the session completely. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल से डिस्क्रिप्शन सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Now let's move further. Question is, a galvanometer shows full scale deflection IG. Resistance R is required to convert into voltmeter range 0 to and resistance R2 to convert to voltmeter range 2. Find the resistance of the galvanometer. To find resistance of galvanometer. In this case, galvanometer is being converted to voltmeter. To convert galvanometer to voltmeter, we have to connect very high resistance in series of the galvanometer. So this point is A, this point is B. In this case, we can allow the current IG. We have to measure the voltage here, V. Now, there are two cases. According to question, case 1, it is a series combination. V will be equal to IG into R equivalent. R equivalent होगा IG R plus G, where G is the galvanometer resistance. Resistance of galvanometer G. This is question 1. In the second case, they are given. This is question the range 2. This is R. This will be now R1. IG R2 plus G. This is equation 2. Now this figure shows to convert galvanometer, we have to connect a very high resistance series with the galvanometer. Ideally it should be infinite. Right? Now voltage across this VAB will be equal to IG into R equivalent. R equivalent is IG G plus R. There are two cases. In the case 1, we have to full scale difference. Find the range 0 to V, so this is V. When 0 to V, then this will be 2 to IG. Now these are two equations available. Dividing 1 divided by 2, we get 1 by 2 equal to R1 plus G, R2 plus G. On simplification, R2 plus G equal to twice R1 plus twice G. So G comes out to be R2 minus 2R1. R2 minus 2R1, that is answer. What is the requirement of the question? A galvanometer shows full scale reflection of current Ig. Resistance R1 is connected. Means first case is, this is galvanometer, resistance R1, this is voltage is V. In the second case, this is a galvanometer, resistance R2, voltage is 2V. Apply this concept, right? Now we get, this is the answer. Generally, voltmeter is connected in parallel. Range can be increased or decreased by connecting the resistance. If the voltmeter is to be increased n times its original range, the value of series resistance should be G into n minus 1. By using this concept, we can find out that, right? Now, next question. A galvanometer, if galvanometer of resistance, this is off. A galvanometer of resistance 100 ohm is converted to ammeter of range 0 to. Given is galvanometer resistance 100 ohm. Using the resistance, shunt resistance given 0.1 ohm. Range is I, we have to measure 1 ampere. Ammeter will show full scale reflection for the current about. Now, what is the procedure to convert? A galvanometer can be converted into ammeter by using a shunt. What is shunt? Shunt is a resistance connected in parallel of the galvanometer. Its value should be very, very small, right? In this case, here I current will flow. Galvanometer cannot allow more than Ig. In this case, apply the KCL, I minus Ig. This point is A, this point is B, this point is C, this point is D. This is shunt. This is parallel to this. So VAB will be equal to VCD. VAB will be equal to Ig into G equal to I minus Ig into I minus Ig into S. Right? Now this G is given, S is given, I is given. We have to find out Ig on substituting and on calculating. We get Ig approximately equal to 1001 milli. We get 1 milliampere approximately. We get 1 millimeter approximately. So B option is the correct. How to convert galvanometer into ammeter? A shunt is a parallel resistance connected in the galvanometer. Value should be very, very small. This is the current, maximum current we can allow here, so I. In the galvanometer, we cannot allow more than Ig. The balance current will flow I minus Ig in the shunt. Now, using the parallel combination concept, VAB equal to VCD, voltage across this will be equal to voltage across this. At this point, we use the KCL. I has been divided two parts, Ig here, I minus Ig here. Now, subtracting, we get 1 milliampere, right? Next, regarding shunt, it is used to protect galvanometer from strong currents to increase the range of ammeter. What is ammeter is connected in series. Range of ammeter can be increased, cannot be decreased. Be careful, right? Now, if the ammeter range is to be increased n times original range, the value of shunt resistance should be G upon n minus 1. By using this formula, we can find it answer, right? Now, next question. The current sensitive moving coil conductor increases by 20%. Let initial current sensitivity is IS1. Then IS2 will be equal to IS1 plus increases by 20%. 20 by 100 IS1. This comes out to be 1.20 IS1 finally. Similarly, voltage sensitivity is voltage sensitivity Vs1 initially is Is1 over R. R1, this is equation. Now calculate the by Vs2. Vs2 will be equal to Is2 upon 2R. Is2 क्या हुआ? Is2 is 1.2 Is upon 2R. We take it, so 3 by 5, this can be written as Vs1. This can be written as Vs1. Now we have to find the what percentage decrease. Now as percentage decrease of any quantity is equal to find initial minus final upon initial into 100. That is the answer. Initial is Vs1 minus 3 by 5 Vs1 upon this will become Vs1. So this comes out to multiply by 100. 1 minus 3 by 5 into 100 to 40%. So decrease will be 40%. The current sensitivity of moving coil will increase by 20. When its resistance is decreased by 2 factor, calculate by what factor does the voltage sensitivity. Now we know current sensitivity increases by 20%. So this will become of 1.20 of initial. What is the voltage sensitivity? That is the current sensitivity divided by the resistance. So initially is this, finally is this, right? We get it like this. Now percentage decrease, this comes out to be like this, right? Next question. Now I will start. Next question, describe briefly how the current sensitivity of a moving coil galvanometer can be increased. Current sensitivity equal to deflection per unit current. In the galvanometer, there is no particularly deflecting torque equal to deflecting torque equal to the restoring torque. NIBA equal to K theta. Using this thing, theta upon I will be equal to NBA upon K. These are the factors on which current sensitivity depends. Means can be increased by using number of turns of the coil. Can be increased by increasing number of turns of increasing the magnetic field strength applied, increasing area of cross section of the coil. Okay. In this phosphor bronze strip is used material using of lower torsional constant. These are the factors on which current sensitivity depends, and if we want to increase, number of turns should be increased, magnetic field strength applied to the area of cross section K should be decreased, right? Next question. A charged particles is moving in the circle path with a velocity v in a uniform magnetic field. If the velocity of charged particle is doubled, the strength of magnetic field is half, then its radius becomes. We know when charged particles enters in uniform magnetic field perpendicular to the direction of field, it is moving that case QVB, centripetal force will be provided by the magnetic force. This goes this, so MV comes out to be QBR. Now, according to question, charge particle means same charge particle. This is same. This is same. What is changing? This is changing. This is changing. We have to find this. These are the changes changing. Which are same, that has to be taken to constant proportionality. Then V1 over V1 over V2 will be equal to V1 over V2 into R1 over R2. Now, according to question, substituting the values, velocity is charge particle doubled. So, doubled means this is V, so this will become 2V. This is V, this becomes 2V. Equal to magnetic field is reduced to half. V divided by 1 by V into R1 over R2. So, this becomes 1 by 2 equal to 2 R1 over R2. R1 over R2 will be equal to 1 by 4. R1 over R2 will be equal to 1 by 4. R2 will become 4R1. R2 will become, means radius will become 4 times. What was the requirement? The B option is the correct option here, right? Again repeating, centripetal force is provided with the magnetic force QVB. Now check what is given in the question. In the given question is given charge particle is same, means we have to consider mass of the charge particle is same, Q as same. Variables are velocity and magnetic field and radius, right? Now which are constant, that should be taken to constant proportion, make the ratios. After making the ratios, substituting the values, we get the final answer. Next, proton alpha particle enter uniform magnet perpendicular to the same speed, same as mv square, as discussed above. Mv square r equal to qvb. Mv equal to qbr, right? In this case, particles are changed. Charge particles are different. Using this is same with same speed. This is same. Changing is mass Q and R. Changing are mass Q and R. Make the ratios M1 over M2 equal to Q1 over Q2 into R1 over R2. In this case, indirectly answer will be found. Alpha particle, so 1 by 4, right? This will become 1 by 2. Proton alpha into R1 over R2. R1 upon R2 comes out to be 1 by 2. This is not the answer. We have to find the ratio of time periods. To find the time period, we use T equal to distance of, speed equal to distance upon time. So, time will be distance upon speed. In this case, 2 pi r upon v. So, Tp over T alpha will be equal to, this is same. So, this will be equal to R1 over R2. This is given to 1 by 2. 1 by 2 is the answer. Let's see what is the answer. A is the correct option. A is correct option. A is correct option. Right? In this case, again repeating, write the formula and according to the question, see which are given, which are constant, which are variable. Which are constant, that will be taken to constant proportion, make the ratios. After put the values, we find the final answer. In this case, we are not getting the final answer. In this case, we first find the ratio of radius. Now we know we have to find the time period. To find the time period, we use the formula speed equal to distance upon time. In one cycle, in one complete circle, 2 pi r distance will be equal to velocity. Velocity is constant, the Tp or Tv will be proportional to the R1 over R2. That comes out to 1 by 2. Now, I would like to request, If you are new to my YouTube channel, Set His Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.